Hello. Good afternoon, all of you. Am I audible? Hello.
Yes, ma'am.
Okay, good afternoon, all of you. Firstly, I welcome all the participants. Behalf of our institute, Dr. Bapuji Saunke, Institute of Engineering and Technology. Today, 21st October 2024, Electrical Engineering Department organized the faculty development program on foundation and design aspects of PV solar system. Before starting session, I welcome our institute director, Mr. BD sir. Good afternoon, sir. I also welcome our institute principal, Dr. Sapate sir. Both these enthusiastic persons always encourage us to do something new. Now I warmly welcome our today's session leader, Dr. Suresh Mikhili sir.
Thank
Firstly, I
you.
introduce him shortly. He's completed engineering degree from Hyderabad University. Also, he was completed MTech and PhD from NIT Roorkela. 50 plus paper publication on his name. It include IEEE and some journal papers. Currently working as a associated professor and HOD of Electrical and Electronics Engineering Department, NIT Goa. Heartily welcome, sir.
Thank you, madam.
And we all of we truly blessed to having such multi-talented person as today's resource speaker. I welcome you on behalf of our team, also our institute. And sir, I request you, please start your sessions.
Okay. Is the screen visible?
Yes, sir.
Yes,
Screen is
sir.
visible.
Okay. Yeah, good afternoon, one and all. First and foremost, I'd like to thank Dr. Bapuji Salanki Institute of Technology, Kolhapur, the principal sir, director sir, as well as HOD of EEE department. So I'd like to thank them for giving me an opportunity to be present here and to deliver a talk on the fundamentals and design aspects of solar energy technologies. Okay, these 5 days it is planned like this. The sessions going will be discussed in this way. So, architecture and vision of the smart electric grid we are trying to see, which includes how the present grid is, how the past grid was, and how the future grid will be. So, in this architecture, we are going to discuss about past, present, and future electric grid. Then, what is the vision and mission of a smart electric grid? We will see. If time permits, I'll try to explain you three-tier structure of smart electric grid. I will explain you. Then after that, the installation capacities. So we are having fuel buys, like by using fossil fuels, by using non-fossil fuels. So what is the installation capacity? Then after that, sector-wise, we are having central sector is there, state sector is there, private sector is there. Sector-wise, what is the installation capacities? Then after that, consumption, the based on application, how the consumption is. So today mostly this one we will discuss. Then tomorrow I'll try to give you history and significance of renewable energy towards this and PV system. Significance of PV system I'll start. Then materials used in the PV system, mathematical analysis of PV cell, PV module, PV array will be discussed. Then after that, mathematical modeling of PV array configurations also I will give you. So if you want make a PV module, PV cell, if you combine the PV cells together, then you will get a module. If you combine your modules together, you will get a PV array. So PV array is constructed from the PV module. PV module is constructed from the PV cell. So how the design aspects will be? So when the PV cells are connected in series, so how much amount of voltage, how much amount of current can be extracted, how much amount of power can be extracted. Then the PV modules. So that means from low power applications to high power applications, we will try to see PV cell design, PV module design, PV array designs we are going to see. So then after that we are having standalone PV systems are there, grid connected PV systems are there. What does it mean? So when we consider a PV system, that means solar PV system, when we consider, you can use for your rooftop application. Suppose you consider your home, on the top of your home, you have constructed a rooftop PV system, and it is serving only for your household purpose, or you have considered a PV plant at your organization, so which is serving only for your institute purpose, but you are not connected with the online grid. That means whatever the amount of power is extracted from the PV system, you are utilizing for your own need. It can be in the industry, it can be in the residential purpose, or it can be in the commercial purpose. So, which is called a standalone system. Suppose if you generate an excess amount of power, and that excess amount of power, if you connect with the grid, and if you transfer some amount of the power generated to the grid, then it is called as grid connected PV system. Okay, so we are going to discuss about standalone PV systems and grid connected PV systems. When you consider grid connected PV system, obviously the design of converters, design of inverters, batteries will play a crucial role. Okay, so we'll try to see that aspect. And one more thing, when you're extracting the power, it can be standalone system or it can be grid connected PV system. But what happens? The performance of any PV system, it depends upon how much amount of irradiance is there on the PV panels and temperature. What is irradiance? So on any of the PV panels at a time, 1000 watt per meter square irradiance will be there with, if there is no shading. If there is a possibility, building shading can happen, nearby tree structure can be there. So if there is any partial shading conditions are there, that means non-uniform conditions, how much amount of power can be generated. So we are going to study that during shading conditions, how the output will be varying. So we are trying to see the performance characteristics of PV system. So if irradiance changes from 0 to 1000 watt per meter square, so we are going to see how the IV characteristics, how the PV characteristics will be. Then after that, if time permits, I told you already in the grid connected PV systems, the converters, inverters also we are going to consider. So that will be the designs will be explained to you. Then the PV integrated EV charging infrastructure will be there. Okay, in the EV, so we are going to consider PV integrated charging stations. So how it will be? Okay, so what type of charging infrastructure we are having? Okay, we have DC and AC infrastructures are there. Okay, so what type of battery standards we need to consider? So PV integrated EV charging station of, if time permits, I will try to cover. Then after that, solar parks in India and applications of solar energy. Okay, so these things also will be covered in the last day. So from architecture of the smart electric grid, then after that installation capacities, significance of renewable energy systems, the materials used, then mathematical modeling of PV cell, PV module, PV array, then after the standalone grid and PV systems, shading conditions, the performance characteristics, PV integrated EV charging station, solar parks, details of the solar parks and applications of solar energy. And one more thing, I'm going to give you any one day, either maybe once you learn this, I will try to explain you how to design a PV module or a small PV array system. It can be series, parallel, or TCT. So in the MATLAB design, I will explain you either fourth day or fifth day. I will try to explain you how to design a PV module and PV array also I am going to explain you. So this is what next 5 days will be. So I will give you at the end of the day, you will try to understand what is a PV cell and what is a PV module, what is a PV array, then differences between standalone and grid connected PV systems. Then if shading happens, how to extract the power, how to enhance the maximum power capability. Then after that, then you are also going to understand how to design a PV system also. I will try to explain you. Fine. So without any delay, we'll move further. If you have any queries, you can ask me at any moment of time. So today we are going to discuss about architecture of a PV system. So the accelerated electrification of clean transportation. First one is clean transportation, charging infrastructure, and 21st century small grid. So clean transportation, charging infrastructure, and 21st century smart electric grid. These three are the contributors for the future proof of secure and clean air objective. We want clean air, we want the secured power. So for that one, what is required? Clean transportation is required, charging infrastructure, and 21st century electric grid is required. Okay. So to meet this, what we are having is we are having two plans are there. One is National Electricity Mobility Mission Plan, NEMMP. National City Mobility Plan 2020 was there. So through this mission plan, what they have considered is the support of first one, clean transportation. What is that? It aims to achieve national fuel security by promoting hybrid and electric vehicles. So here promotion of electric vehicles is done with the help of NEMP, National Electricity Mobility Plan. What is the target they are having? 6 to 7 million sales are there. Okay, so their target is 6 to 7 million sales they want to do by 2020. So what they have initialized, I told you know, if time permits, I'll explain you EV. So under this, they have initialized FAME India scheme. What is that? Faster adaptation of manufacturing hybrid electric vehicles. There is a FAME India scheme is there. So through that, they are supporting 10,000 crores for development of electric and hybrid electric vehicles. Okay. Next, that is supporting of electric vehicles. What happened? Clean transportation is possible because you are considering EVs. So that is clean air objective you can achieve. Second one is National Smart Grid Mission, NSGM. Through NSGM, what they are considering is grid modernization they are going to do. In the grid modernization, they are going to consider 21st century smart electric grid. What is 21st century smart electric grid? The coming slide I am going to explain you, which includes sensors throughout the network, which includes EV PV integrated charging stations throughout the network. That means we are going to have the grid modernization, which includes the PVs, electric vehicles, wind energy system, hybrid renewable energy system we are going to have in one shot. So why we are going for it? The reason is we want to generate renewable power generation was by 2030 500 gigawatt. Excuse me. So we want to generate 500 gigawatt by 2030. Okay. So India's current objective is to reach 500 gigawatt of installed capacity from non-fossil fuels. Remember, what does it mean? So through solar, wind, the hybrid renewable energy system, through that, they want to generate 500 gigawatt. Why they are doing? To reduce the carbon emissions, finally to improve the air quality. I hope it is clear. To reduce the greenhouse emissions and to improve the air quality, they are going to focus mainly on renewable energy systems. Out of which is the promising one is solar energy systems, wind energy systems are the promising ones which can give the more amount of power can be installed, more amount of power can be generated. So to meet this, they have considered these two plans of which is that NSGM, NEMP they have considered. Fine, I hope you understand. Okay. The new entrants in the power sector is you see the PVs, EVs, then smart meters. New entrants in the power sector are photovoltaic systems, solar, PV systems, electric vehicles, smart meters are the new entrants in the power sector which will contribute, okay, clean air objective. Okay. So what is the vision of smart grid for India? Okay. Transforming the Indian power sector into a secure, first one is secure, adaptive, sustainable, and digitally enabled ecosystem. So we want to transform Indian power sector into a secured power we want. That's what the first one observed, I think. So we want secured power. Okay, it should be adaptive in nature, sustainable for a longer period, and it should be digitally enabled. If you have this system, then what will happen? Which will provide reliable and quality energy to the stakeholders. My main motto is reliable and quality energies to be given to the stakeholders. To meet that, I need a secured power. How I will get secured power? So here they are going to
ए
consider
मम्मी
ICT, information and communication technology. They are going to consider. Okay, cyber security and protocols they are going to consider. So try to understand. If you want to transform Indian power sector into a secured power, they are going to implement information communication technology. That means smart meters they are going to install in the entire power system. So that what happens, easily you can secure the power with the help of information communication technology, and you can acquire the data through the grid intelligence. Second one is whatever you are considering in the grid, it should be adaptive in nature. What does it mean? When you consider a 21st century smart electric grid, whatever the components you are including in the grid, it should be adaptive. So when I'm explaining that future smart electric grid, I will show you that. Okay, so here what it is, whatever the components for generation side or transmission or in the distribution side, whatever you are including, it should be adaptive in nature, and whatever the technology you are considering, it should be sustainable for longer periods, and that it should be digitally enabled ecosystem you need to consider. If you see the previously when we consider, this is generation and transmission distribution was there. So previously there was a dumb electricity was there, and we are having communication protocols as well. We are having separately, we have generated power which is transmitted and distributed is there. We have a communication network is there. What we are doing, we are merging the communication network and energy networks. So if you merge the communication network with the energy network, what will happen we'll see. Try to understand. Previously we have separate generation was there and transmission distributed power is there, and now what we are doing, we are merging energy network with the communication network in such a way that what happened, throughout the network now we are using the smart meters. Throughout the network, when we consider smart meters at each and every field terminal point, what is that field terminal point? At each and every field terminal point, we are considering the smart sensor throughout the network, then real-time simulation is possible. So when you have a smart meters installed at each and every station, so we can acquire how much amount of real power is available, how much amount of reactive power is available at that point. That means how much amount of demand is there, how much amount power can be injected, whatever the loss is. At each and every point, we can
बंदा
sense
टॉप
the
पे
data.
थे
Excuse me. Can all the participants can mute your systems? So real-time simulation is possible. Excuse me.
ए बंदा टॉप पे थे
So wide area reliability will be increased. Wide area reliability means, so when you have the field terminal points at each and every point, then so there is a possibility the reliability will be also be increased. The network optimization is possible. How can you optimize your network? See, if you able to know how much amount is generated, how much amount is transmitted, and how much amount is distributed, then it is easy for the person so to do the network optimization is quite possible. And also, what will happen when smart sensors when you are considering, so along with the real-time simulation, reliability increase, network optimization when you are doing, you no need to go for investment on the new power plants. You can participate in the energy markets, and the customer participation will be increased. So I hope you understand. So you are merging energy network with the communication network. So smart meters you are installing from generation to till distribution point. Real-time simulation is can be done. At each and every point you can get the acquire the data. Then wide area reliability will be increased. The network optimization is possible. Then customer participation will be enhanced, and you can participate in the energy markets too. So now we see how the past grid was, then how the future grid will be. When we consider the conventional grid, it was, so when you consider the past grid, it was electromechanical. It was just one-way communication. So what happened? So the power generated will be centralized. Only at one particular place it used to be generated, and which will be transmitted and distributed. So and there were very few sensors were there. It was manual monitoring and manual restoration, and there were the failures and blackouts were there. It was a limited control and choice for very few customers. Now, what we are doing in the future grid, in the smart grid, so we're going to consider digital system, and which is of two-way communication, which is of two-way communication we are considering, and throughout the network, distributed generation we are considering, and self-monitoring and self-healing is possible, and which is adaptive in nature and islanded condition. It is a choice for many of the customers. Okay. So when we see the past grid, how it was, generation was through coal. Generation was thermal power station. Power was generated. When you see here, one is power flow. Second one is information flow. When you consider a power flow, so power is generated is through the thermal power station, which is transmitted and distributed to the customers of residential, commercial, and industrial. So when the information when they want to take, so they used to collect the data from generating fields, and transmission and distribution. They used to collect the data through telephonic operation. So when you observe this, we have so both a thermal power station we were having, and hydropower was there, and we have only telephonic operator used to be there in the substation. He used to collect the data information from all the fields like generation, transmission, and distribution. There was no grid intelligence. But if you consider the present system, how the present system is, when we consider the present system, along with the conventional power, we are having non-conventional energy sources we are having. What does it mean? So we have a renewable energy of solar PV system is there, and we are having wind energy systems are there. In the present system, along with conventional thermal energy, we have the PV power is there, and we do have the wind energy systems are there. Okay. Not only at utility level, even PV systems, if you observe, now we are having in the form of rooftop PV at residential level also, we do have the PV systems we are having. Previously, we have only thermal was there. At present, along with the thermal, what we have, the PV and wind is there at utility level. But at residential level, we have rooftop PV systems are available. And when we consider transmission and distribution, we are having a SCADA system is the supervisory controlling and data acquisition is available. Okay. So the information how we are collecting, the previously it was through telephonic operator. The at present we are considering the data through SCADA system. Okay. We have a transmission control and distribution control. Now you see this. If you observe, extra is solar and wind is added to that, and we have there is rather than telephonic operators, we have a SCADA system of phase measurement units are there in the substation. So they have supervisory controlling and data acquisition units are there. Even transmission distribution control also. So they have SCADA systems are available. If you observe clearly, it is not only in the present system, not only just PV at utility level, even most of the houses we have the rooftop PV systems are there. That means small amount of power can be generated with the help of the rooftop PV system. So small amount of power can be generated from the rooftop PV system. There is a burden on the power system will be reduced. Load demand will be reduced and load profile optimization can be done. Okay. Now, even some places at this moment of time we have EV charging stations also there. So how it is EV charging stations? A charging point facility with electric vehicles is there. So here how the power flow? Power is generated, which is transmitted to the transmission network and which is distributed. Even small amount of power also generated at the rooftop. But when you see the future grid, the how it is. Can you Can you consider a future system? So along with the conventional energy, so we have the PV, wind, and hydropower is available. Okay. So now we are having renewable energy systems are there. So along with that, what we are having is just like the present grid, future grid also will have PV integrated EV systems are there. Okay. And not only that, through the transmission, if you observe this, this is transmission. Throughout the transmission and distribution, what we are having, EVPV integrated charging stations are available. So when we have a EVPV integrated charging stations, so what will happen? So previously it was just EV charging station. The future is going to be EVPV integrated charging stations. This throughout the network. And throughout the network, we will have a smart meters. Throughout the network, we will have a storage system. Then what is going to happen is just let me show you that. So like this. So solar and wind is there at utility level and rooftop PVs are there at household, at commercial buildings. Okay. Not only that, throughout the network, when you observe in highways, if you go to highways, so we are having windmills are there. You might have observed or not. In the national highways, when you go, we will have windmills are there. So throughout the network transmission and distribution, we are able to integrate the wind energy systems to the grid so that it is generating as a distributed generation. It is generating. Not only that, we have some solar parks are available. So there are solar parks are available different places. So power can be generated with the solar parks also. Not only that, as I shown, the future EV charging station, if you enable with PV integrated EV charging station throughout the network, it is like this. Even if you have electric vehicle EV charging when you are going, top of that vehicle, if you have a PV enabled EV charging station, what we can do? So how much amount of power required for an electric vehicle can be generated with the help of EV charging station. So that what will happen? So I will show you that on slide and I'll come back here. See, previously EV charging was even at present also. EV charging is like this. If you have an electric vehicle charging is like this, what will happen? How much amount of power is required for the electric vehicles? The entire burden will be taken by the grid only. But if you consider EV charging is like this, what is going to happen? You can generate or you can extract the power. If you have a solar PV panels, you can extract from the sun, you can extract the power with free of cost, and with the extracted power, so you will have a battery management system you can store in the battery, or else if excess power is not there, directly you can charge your vehicles. That means whatever the power required for charging your vehicle can be extracted naturally, and you will be less dependent on the grid. So here if you observe on top of one car, if you observe, how many panels are there? One, two, three, four, five, six, seven, 8 panels are there. Now, you consider one panel is of 500 watt is there. Every panel comes in the range of 200 watt, 300 watt, or 370 watt, and 500 watt panels are there. If you consider 500 watt panel of each panel, so there are on top of one car, if you consider suppose 8 panels are there. So how much power can be generated installed on top of one car? There is 4 kilowatt power can be installed. You assume that you are having suppose 10 vehicles are there for a charging. One side is 5 vehicles, other side is 5 vehicles. So total on top of one vehicle, if you are able to generate install 4 kilowatt on top of 10 vehicles, you can install. On top of 10 vehicles, you can install 40 kilowatt power can be installed. Try to understand. So if I have electric vehicles like this, then how much amount of power required for charging the electric vehicles is fully depends upon the grid. But if you have the PV integrated EV charging stations, you can install minimum 20 to 40 kilowatt of power can be extracted from the sun, okay, and free of amount, then you can charge your vehicles. The burden on the grid will be reduced. So then what will happen? The future, if you go ahead with PV integrated EV charging stations, definitely there will be. You think like this is for one place, like this. If you have all over the India, if you have where outskirts of the villages or outskirts of the cities, if you have a PV integrated EV charging stations, how much power can be generated? You think of it. Okay, so that's why the future is going to be in the future. In the future, we are going to consider PV integrated EV charging stations. We are going to consider. So this is the future grid. So we have solar and wind is there in the utility, and in the transmission and distribution you are having wind energy systems are there, and solar parks are available. EVPV charging stations are there throughout the network transmission and distribution. At the distribution also we do have PV rooftop PV systems are there at commercial level, at household level. So these are the future grid. And along with that, we are also going to consider smart meters throughout the network, so that the power will be digitally enabled ecosystem we are going to consider. So that's what. So when I said the first one, so what it is, so clean transportation required. Yes, when you consider which one, hybrid renewable energy system like wind and solar systems, then clean transportation is possible. Charging infrastructure we are considering 21st century grid. When we consider easily what we can get, the clean air objective can be achieved. So if you consider PV system, which is adaptive in nature. PV and DV systems when we consider are smart meters, which is sustainable for longer periods. When we consider smart meters, it is digitally enabled ecosystem. When we consider information communication technology, the secured power we are getting. So through this, this is the past, present, and future grid will be. Okay. Now, we'll try to see when we consider the HVAC system, what we are having generation of 11 to 25 kV we are generating. So, as we aware, we have a step-up transformers will be the 11 to 66 kV, then primary transmission, secondary transmission will be done, primary distribution, and secondary distribution will be done. Then there are customers will be there. Okay. So, how we will do? Nowadays, we are having a range of a transmission is high voltage transmission is there. If it is an extra high voltage transmission, even we are having either 400 kV or 765 kV transmission is there. So for high amount of transmission, what we are doing first, 11 to 66, 66 to 220 kV. From 220 kV, we are doing either 400 kV step up or 765 kV. So extra high voltage transmission systems, so we are stepping up and transmitting high amount of voltage for efficient power transmission. Then after that, we are stepping down. So every city outskirts we will have 33 by 11 kV substation will be there. So 11 by 400 volts household purpose we are using. And similarly, it is normal high voltage system. We are having 11 by 33 kV is enough step up transformer. 11 by 33 kV is enough. 33 by either 110 or 220 kV will be considered. Only high voltage system up to 400 kV we are considering. If it is extra high voltage, 765 kV consider. This is for HVAC system. If you consider HVDC system, again we will have a converters, inverter stations will be there. Then the high power can be transmitted. So now if you see, so in the future, the fully it will be like this. The future is going to be, so will have a power will be generated through both conventional and non-conventional energy sources. Then data is transmitted even at your household itself. With a rooftop PV systems, you can generate the sufficient power how much amount is required. Even you can use that rooftop PV system to charge your electric vehicles also can be considered. If you have a storage, if you consider. Okay. So in future, what we are considering, there is a microgrid and bulk grid applications will be there. In the microgrid, we are integrating solar, wind, diesel generators, batteries, and all together, if we small amount of power if we generate, if a small amount of power is generated, we are giving to the grid, it is microgrid controller. But if you are generating a large amount of power, if you are generating a large amount of power, then which you want to give it to the system, it is a bulk grid application. Okay, so I hope you understand this. Now, so when you consider on the system, so what it will be? So when you consider impact of distributed energy resources on the utility grid, when you consider, okay. So there are, we need to see how the grid reliability is there, how the grid reliability. Then we also need to see how the grid flexibility is. So how the voltage and frequency regulations, any grid integration challenges are available. We need to check. Not only that, so we also need to see the grid planning and operation need to be seen. Grid congestion and demand response has to be seen. Okay. So how to check the grid reliability? So when we consider smart electric grid, so previously what happened? So previously when we see normal system, okay, past grid when we see, so we were depending on what? When you see the past grid, we were depending on the power generation of from at one level, which has to be transmitted and distributed to load, but which is very highly difficult. Like there are line losses are so many are there. So whenever the small amount of loading increased, the entire thing will be burden on the grid only, this much distance when they are transmitting. But now what happened, we have in the future grid, we have in the form of Rooftop PVs is there, residential level, commercial level, industrial level, and we have EV PV charging stations are there. We are generating the power. We are generating the power through wind system. We are generating power through. So many distributed generations we are having, as well as not only distributed generation, we have a microgrid operations also we are considering, and EV PV charging infrastructures we are having. Okay, so through which what has happened, so through which there is a possibility of through the smart grid. Okay, we are integrating renewable energy with the grid. Okay, and in that smart meters, sensors, we are doing network optimization. Okay, real time monitoring we are doing, control and optimization we are doing. So grid flexibility definitely high when we consider here. Have to understand. So, so grid reliability will be very, very high. Why? So if you want a power, definitely easily accessible is here we can generate power. Here we can generate through EVPV charging station generation is there. So grid reliability is increased in the smart electric grid. Okay. Even grid flexibility is very, very high. Why? We have a bidirectional power flow. How it is a bidirectional power flow? Try to understand. When we consider high amount of power is generated on your rooftop, if you utilize yourself, that is normal standard system. But if you connect with the grid, either you can dump the power into the grid or you can extract the power from the grid. So bidirectional power flow can be happened on the grid also. Okay. So even what benefits will increase? Okay. Greenhouse emissions will be reduced. Why greenhouse emissions are reduced? Carbon emissions, why it is reduced? Since we are using most of the energy is generated through EVPV integrated and wind energy systems, so it will be green, greenhouse emissions will be reduced, the energy cost will be saved, then clean air objective environmental benefits will increase, and flexibility scalability will be enhanced, and energy cost will be reduced. If you see the previously, when we consider the past grid, how it was, so when you see utility level only wind was there, PV panels were there, generation transmission, even some commercial buildings we were having this one. Okay, so now the future what is required is we want essential elements in the smart grid required is deep energy efficiency we are expecting, and demand management it has to take care. Grid intelligence is possible, clean power is possible through electric vehicles, and energy storage is possible. With the help of smart grid, deep energy efficiency is enhanced. How efficiency is increased? Because you are using in the form of DGs, in the form of microgrid, we are considering the PVs, EVs, wind. So efficiency is increased, line losses are reduced. Still, if you have the previous grid, in the previous grid, you are depending from here to here, losses are more. In the present grid, you are taking how much power is required from your home, from rooftop to home you are taking, or rooftop commercial to building you are taking, or solar PV charging station to electric vehicle you are taking, solar parks to the transmission line you are taking. So wherever the power requirement is there in the form of DGs and MGs, when you take the power, so definitely in the future grid efficiency will be increased compared to the past grid. Demand management is possible. Obviously, you have a wind, EVPV structures are available. Definitely, demand management will be easily possible, and grid intelligence is enhanced. How it is enhanced? Since you are using the smart meters, grid intelligence can be enhanced. So, clean power you are achieving, and electric vehicles we are considering. Okay. Now, through which what is enabled is the foundation level. If you see circuit topology wise, feeder optimization, substation optimization we are doing, gas insulated substations we are considering. Okay, which applications are there? The feeder optimization, substation optimization we are doing. We are adding in the first slide I told you, we are merging energy network with the communication network. So the communication protocols we are considering throughout the network, IT infrastructure we are considering. So foundation level circuit topologies, the network communications, We are merging. Second one, what fundamental application we are considering? When you do substation automation, distribution management, automatic distribution management is possible. And smart meters you are installing. And when you consider these things, electric vehicles we are considering, we have a plug-in EVs are there, energy storage, battery management system is there, through which reactive power compensation can be done, efficiency can be enhanced. The motto is to improve the efficiency, we are reducing the reactive power, we are reducing the losses, we are doing grid optimization. Okay, we'll see the second part, the electricity sector of India when we consider. So, electricity coverage, how much is there? Electricity coverage is almost 99.94% is there, electricity coverage. The installed by 2019, it was 99.94 percentage, and installed capacity was 441 gigawatts actually, 4,41,969 megawatts, which is equal to 441 gigawatt. Okay, the production is 1,948 terawatt hours, and gas carbon emissions are 2,300 million metric carbon is emission. Try to understand. Green emissions are, because of this, 2,300 million tons of the gas emissions are reduced. Okay, so the transmission losses are 17 percentage. Now I will show you consumption by the sector. Okay, so we have residential is there. Residential sector we are using the power. Industrial sector we are considering, as well as agricultural, commercial, traction we are considering. When we consider for a residential purpose, as of 2022, 25.77 percentage, approximately 26 percentage of amount of energy generated will be consumed by residential people. So consumption of residential people is approximately 26 percentage is consumption by the residentials. And in the industry, by the industry, the percentage of energy consumed by the industry is 41 percentage, and agriculture it is 17 percentage. Okay, and commercial is 8 percentage, traction is 1.5 percentage. Try to understand. For household purposes, residential areas when we consider, okay, most of the household purpose generated amount of energy only 25 percentage is utilized. If we generated 100 watt, only 25 watt is used for residential purpose. But industry has a highest share. The consumption by the industry is 41, 42 percentage it is. Mostly, how much power we are using for residential, almost agriculture also we are using similar way. The 17.6 percentage is utilized for agricultural field, the whether the motor applications are there we are considering. And commercial purpose, what is the commercial meaning? So when you have shopping complexes are there, multiplex is the shopping complex, multiplex, theaters. So these multiplexes, commercial areas, whichever the buildings, theaters, everything, 8% share is in consumption was taken by the commercial buildings. And for traction, rail applications, road and rail applications, energy power consumed by traction applications, it is 1.5%. I hope you understand. Okay. Now, who is setting these policies? Who is responsible for policy setting is the Ministry of Power is responsible for the policy setting. Ministry of Power is responsible for policy settings, and out of these policies, suppose our power is combination of both renewable and non-renewable asset. Now, how much amount of PV required? How much amount of wind is required? How much amount of thermal is required? So everything policy is set by Ministry of Power. But responsibility of renewable energy is taken by Ministry of MNRE, that is Ministry of New and Renewable Energy is their MNRE. MNRE takes purely renewable energy responsibility. Okay, and second thing, when you generate the power, I told you clean air objective is required. So how to maintain the clean air objective? How much amount of gas emissions can be there? So Responsibility for the environment will be looking after by Ministry of Environment and Forest and Climate will be there. Entire thing works on Electricity Act 2003. I hope so. Electricity coverage is 99% and installed capacity was 441 gigawatt and production was 1948 terawatt hour. Greenhouse emissions are 2300 and average electricity is 1395 kilowatt per capita and losses were 18%. We have the consumption by residential, industrial, agricultural and commercial traction is there. So when we consider residential, okay, then it is 25%, industrial 40, agricultural 18%, commercial 8, and traction is 1.5. Okay, now we will see. I told you total installation capacity. Okay, sector wise, when we consider central sector was 23% shares is installed by central. Okay, out of 450 gigawatt or 4,000 lakh 50,760 gigawatt. Okay, this is of data as on when? As on 31st August 2024. As on 31st August 2024, the installed capacity by central government is 23% share is by central government and state governments has installed almost equally 24 percentage, that is 1 lakh 8,000 megawatt, and the private sector holds 52 percentage, 53 you can say. So installed by the power is installed by private sector is higher than the state and central government. I hope you understand. Central sector has installed 23% share out of 4,50,760 megawatt. State has installed 24 percentage of power and private sector has installed, okay, how much? 53 percentage of share is installed by which one? Private sector. Now you see, I want to give you fuel wise. So when you observe as a fuel wise, we have a fossil fuels are there. Okay, non-fossil fuels are there. What does it mean by fossil fuel? We have coal, lignite, gas, coal, lignite, gas, and diesel is there. When we consider it, out of which fossil fuels, total amount of share by fossil fuel is how much? 54% is 54% share is fossil fuels and non-fossil fuels is 46% share. Out of 4,50,760 megawatt, we are generating a power with the help of fossil fuel is 54 percentage and non-fossil fuel the percentage of power is 46 percentage, out of which highest power generation is by which one? Thermal only. That's why coal only we will show generally. The thermal power is 46 percentage share by thermal itself. Lignite is just 1.5 percentage. Gas is, no, oil and natural gas. So gas is just 5.5% share only it is out of 4,50,000. And diesel is very, very small amount, 0.1 percentage share. I hope you understand. So fossil fuels, we are generating 54 percentage and through non-fossil fuels, we are generating 46 percentage and out of which coal has the highest share and next is the renewable energy. What is that? Hydro, through small hydro we are generating 10 percentage, through wind 10.5 percentage, through solar 20 percentage of amount is generated by solar itself, and biomass and biogas those things are 2.3 percentage, waste to energy is 0.1 percentage, small hydro is 1.1. Okay, wind, solar and renewable together 33 percentage we are generating. Hope you understand. Hydro and wind is 10-10, but solar is 20% we are generating. This is what the statistics of fossil fuels, how much we are generating, and non-fossil fuels, how much power we are generating. Okay. Now, So if you see overall generation, how much it is increased year by year, at least 9 percentage is increasing. Suppose last year to this year, thermal power generation is increased by 9.98 percentage, nuclear just 4 percentage increased, that's it. Hydro 17 percentage, but solar and wind is also 10 percentage. But import, how much we are doing? Reduced by 30%. Try to understand. Generally we will Generally, we will import the power from Bhutan, that is reduced by 30 percentage. Okay. Generation of hydro also reduced by 17 percentage, but solar, wind, renewable energy is increased by 10 percentage, and overall generation is 7 percentage is increased. So importing is reduced, but exporting and generation is increased. So overall is 7% is increased. If you see the growth, how it is, if you consider annual growth in fossil fuels, thermal generation is every year approximately 6% or 4%, 10% is there. When you see COVID time, 2019 to this particular time, if you see, so here we have not generated anything. Okay, through the thermal, we have not generated anything. But renewable energy, if you observe, but renewable energy, if you observe, so almost more or less the growth is increased. Only 2021 time only, where the COVID time is there. So there, except that period, remaining all the periods approximately 5 to 10 percentage of growth is there every year. The installation capacities are generation is every year increased by 4%. Why we are increasing like that? To meet the criteria of increased load demand. See, there is a statistics says that every 10 years it doubles the capacity of the loading is increases. Try to understand. Every year 10 percentage of at least loading is increasing. So by 10 years, your load is double the actual load. So every year, if you target minimum 5 to 10 percentage, so then you can maintain the demand response, or else you can't maintain the demand response. I hope you understand. Okay, so why we are increasing every year 5 percentage? To meet the increase in load demand, then we are increasing these powers. This is what the requirement. How much is there? How much amount of availability is there? Okay, requirement is 8 lakh 30,000 million units. So how much available is 7 lakh 46. So this is the deficiency levels. Okay, so this is what the power is generated, including renewable energy. How many million units is year by year, how much we are generating. Okay, you know, one more good thing is India is the third largest producer of electricity in the world. Okay, this is what the share, the percentage wise. The coal is 49 percentage generation. I told you the black one is coal. The lignite 1.6 percentage, gas is 6 percentage generated, diesel 0.1, hydro 11, then wind, solar, other things together 30 percentage. Blue one. This is installed capacity. How much you installed? Try to understand. Installed is different. Generation is different. If you install, how much amount of installation is? If 10% if you have installed, it does not mean 10% you will achieve. Out of that much installed capacity, some amount will be generated. Try to understand. The coal installation was 2 lakh 5,000 megawatts. Coal generation was 1 lakh 78,000. That means almost 72% is extracted mainly from the coal only. The installation is 2 lakh, extraction is 1 lakh 78, 1 lakh 80,000. Only 20,000 megawatt of loss is there, and large amount of extraction is through the coal. Even large hydro is there. If you take the hydro, so how much? 10% only you can generate. Small hydro 0.7 only. Wind extraction is 4.6 only. Even solar and wind is 5% only we can extract. But compared to that, the coal extraction is very, very high. Okay. This is the growth. Going to show every year by year. This is also by 31st August. So which share is high? Installation capacity is coal is this much, and when you see oil and natural gas, nuclear is very small. If you see red color, nuclear is very small. Whereas solar, if you see year by year, it is increasing. Yellow color, the yellow color year by year, installation capacities are increasing like anything. But whereas your coal is constant, it is almost, but wind and solar is, even wind you see blue color, wind and solar is increasing year by year, even solar is drastically increasing. Why drastically increasing? Now you see Modi has announced one 1 kilowatt for 1 crore houses. That means 1 crore kilowatt power can be installed on the rooftops. 1 kilowatt, if they're going to give as a subsidy, you can install even up to 3 kilowatts. 1 kilowatt they are giving, and you are installing on that one, that how much it is there, you try to see. Okay, these are the generations. National level installed capacity is this much, and net capacities are these are. Even we have all India level, we have a northern region is there, we have western region, southern region, east, northeast, islands is there. So how much share is there? Even the region wise also given. So we will try to, I will try to give you brief introduction to solar. For, okay, so tomorrow I'm going to discuss on the main on PV systems. Then after the types of PV panels, what we are having. So types of different monocrystalline, polycrystalline, then thin film is there. What is the structure of a monocrystalline, polycrystalline, advantage, disadvantages of both monocrystalline, polycrystalline, we will see. Then tomorrow we are also going to see the components of solar PV systems, like what supply we are having, what type of interfacing we are having, what type of loads are there. Then after that we are having standalone systems are there, grid connected PV systems are there. I'm going to explain you about first what is a standalone system, what parts are available. Next I will explain you about grid connected PV system also, how the structures will be. What is the difference between standalone and grid connected also, I will explain you clearly. Then we have hybrid PV systems are there. Okay, so I will try to give you hybrid PV system structures also, I will give you. So tomorrow I'm going to explain you about mainly the basic significance of how the photon energy we are generating from the solar PV cells. Then types of PV panels what we have. Then after that comparisons of PV panels we will try to see. Then which components we are using, and there are types of systems are there, standalone PV systems and grid connected PV systems. Then there are shading conditions are there. Okay, the cloud based, or maybe when there is building structures are there, when there are trees are there, how the shading will happen. So how these IVPV characteristics will change by varying irradiance. So different. This is you see 1000 watt per 250 square watt per meter square, 500 watt per meter square, 750, 1000 watt per meter square. By changing irradiance, how it is IVPV characteristics are changed. Okay, if suppose if I change the temperature, first one is by changing the irradiance, there is a change is there. By changing this one, you see temperature 0 degrees to 75 degrees of temperature increase. How the voltage is changed, how the current is changed. Understood? Tomorrow we are going to discuss this. Then after that, so we have mathematical modeling of a PV cell is there. From one cell, after the cell, then I will take you to module. After the module, then PV array. Then PV array architectures are there. Even solar parks where we are having. So we are going to discuss mainly on mathematical modeling and PV cells we are going to see. Okay. So along with that, one more is there. there is a smart electric grid architecture. After that, one is there. Which one is Indian smart grid journey? With that, I will close today's session. So we have an NSGM structure. I told you, no. In NSGM structure, what we have, it is a three-tier structure. Is there National Smart Grid Mission? So we have a three-tier structure of. We have a Ministry of Power will be there. I told you, no. Ministry of Power, MNRE, as well as the environment aspects. So tier one, we are having Ministry of Power, Governing Council will be there. We have a three-tier structure. In tier two, we have Secretary of Ministry of Power. Here we have Empowered Committee will be there and Technical Committee. Empowered Committee will look after the financial
Hello.
things. Technical Committee will look after the technical aspects of what policies need to be implemented. It is chaired by Power Grid Corporation of India chairman. Okay, we have a three-tier structure in National Smart Grid Mission. So in that, what we have is we have a Ministry of Power is there. Then we have a empowered committee of secretary will be there. So who will take care the financial things? The technical committee, we have a chairperson will be there who will take care of all the technical aspects. After that, we have a tier 3 structure. What is that? Under that empowered and technical committee, there is a national smart grid mission. The project management unit will be there. What is that? So we have under NSGM, National Smart Grid Mission, there are four units will be there. What is that? One is policy planning monitoring unit, which looks after which policies need to be implemented, what type of policies need to be implemented, where we need to plan, when to plan, what to plan. Try to understand what are the policies we are having, which will be set by NSGM structure, or that is of Power Grid. So if we have a different policies are there. So where to plan, which city we need to plan, okay, or which state or which district I need to plan, which state I need to plan, and what to plan, when to plan. Everything will be taken care by policy planning and then monitoring unit. What it will do after installing that policies, then they will monitor, is it working properly or not, how the work is there. So everything will be as per the standards, is it working, or as per the expectations, is it working or not. Policy planning monitoring unit will take care. Second one is data management and security unit, which will looks after. So how much amount of power is installed, what type of meters are installed. Okay, so transmission losses you have seen, no, 17%. So how much amount of units are installed, how much power can be extracted, how much units are built. So is there any power theft is there? Is there any cybersecurity issues are there? Or whatever installed capacities are there, is it able to generate as per the requirement or not? Data management and cybersecurity unit will take care of that. So before implementing these two things, what is required? There is R&D technology standards unit is there. What it will do? So in the R&D technology and standards unit, this R&D technology group, first what they will do, here I told what policies need to be implemented. So all the policies are designed by R&D technology unit. Do you understand? So what type of PV panels need to be considered? What type of EV architecture need to be considered? Is it DC power? Is it AC power? What type of batteries are considered? What type of smart meters are required? How the standard should be? Entire A to Z from generation to till distribution. R&D technology
Sorry, sir. Sorry for The disturbance. Please
Madam,
continue.
you can take the control over, no? Can't you mute everyone? See, in the tier one, we have a Ministry of Power. In the tier two, we have Secretary will be there, and who is chaired by Empowering Committee will be chaired by the Secretary Ministry of Power, and we are have a Power Grid Corporation Central Electricity Authority. Okay, Technical Committee Chairman will be Central Electricity Authority. Now there is NSGM Project Management Unit. 4 units will be there. So in that priority one will be the first one will be R&D unit. R&D unit looks after, okay, what type of meters need to be, what is the standard of that units, okay, so which type of technology need to be considered, okay, or how the technology, even including from transmission to till distribution, okay, what are all the changes need to be done, this R&D technology will first propose the things. After that, what they will do, after proposing the things, then there is project training and capacity building unit is there. So they will try to, once the proposal has come, once the concept has given by R&D unit, okay, then there will be pilot projects wise, the projects and training capacity building unit, in a small scale they will develop the things, in a small scale they will develop the things, and they will try to build the things, they will test it. Once they feel that a small scale project is properly developed and it is meeting the requirements, then only first R&D unit will develop the things, and after that it will testing will be done. Once it is done, they will go for policy and planning implementation, okay, and then they will monitor. Then after that they will check the data management system and cyber security issues will be considered. So everything will be done through smart grid knowledge center is there. What is that? These R&D projects as well as the project management unit is managed and controlled by smart grid knowledge center, which is in Manesar, okay. So then when you are considering the policies planning, so there is the consultants and advisory bodies will be there. So they will consult, these consultants and NGOs advisory bodies, they will design these policy settings. They will plan where to install, what to install, when to install, what type of security issues are there, what is the privacy issues, everything will be designed as per this three-tier structure by consulting these people. Now, this is central level. When it comes to state level, what we have, state level project management unit is chaired by state secretary of Ministry of Power. So we have distribution utilities are there, smart grid cell, consumer local bodies will be there. Second, one second. Now you can see clean. So these people, what they will do, if you observe, in consultation with these advisory bodies and smart grid manager, so they will try to establish each and
Hello, hello.
everything. Okay. So I hope you understand. So what we have, just an outline I will give you for just 5 minutes. After that, I will open for the queries. So what we have is, when we consider the motivation is, we want a secure and clean air objective required for electrification of clean transportation, charging infrastructure, 21st century grid. We have two plans are there, NEMP 2020, second one is NSGM is there. Through NEMP, we are going to consider EV promotion. Through NSGM, grid modernization we are doing. Why we are doing is, we promoting renewable energy system, non-fossil fuels. Through that, we want to generate 500 gigawatt by 2030. At present, our installation was 446 gigawatt only, 450 gigawatt. By 2030, the entire, why 500 gigawatt? At present installation capacity 446, the entire coal and renewable together, if you want to generate only by renewable, then we can see full clean air objective can be seen. That's why the target was 500 gigawatt. So why we are doing? Reducing the green emissions. These are the new entrants, PV, EV and smart meters. Then vision for smart grid India we have seen transforming Indian sector into secure, adaptive, sustainable, enabled system for reliable quality application. And what we have seen, we are merging energy network with the communication network. By merging this, real-time simulation possible, wide area reliability increased, network optimization is possible, customer participation will increase, and we can participate in the energy market. Then we have seen the differences between the conventional grid and smart grid. In the conventional grid, it was electromechanical, but smart grid is digital in nature. It was one-way communication. Now it is the future grid will be two-way communication. The previously what we were having, it was central generation, but in the present grid, distributed generation. How it is distributed generation? We are having PVs, wind farms are there, EV PVs, charging stations are there, rooftop PV systems are there. Throughout the network, we are generating the power. So that's why the power is distributed in nature. Okay. In the smart grid, sensors we are using throughout the network. Previously, very few sensors were there. That's why self-monitoring, self-healing is possible in the smart grid. That's why it is choice for many customers. It is a fully controlled system. It can be used for islanding application also. What is meant by islanding application? Suppose if you have a PV system is there. So where islands are there, where there is no power supply connection, where is very remote area, there also I can consider a PV panel and you can extract the power. Okay. So past grid, what we were having? So we were having power generated through only conventional energy, that is through coal, only central generation which is generated, transmitted and distributed. And when you want the information, it used to be collected from generation, each and every field points, okay, through the telephonic operator. Okay, this was the past grid. In the present grid, along with the conventional energy, we have included which one? Renewable energy through PVs, wind. Not only at generation, at distribution also we have considered solar systems, rooftop PV systems. And the previous it was telephonic operator used to collect the data. At present, we are using SCADA systems we are considering to collect the data. You see, we are having substation SCADA systems we are considering. Okay. So future is what we are considering. Along with the conventional energy, we are considering EV PV integrated systems, and what we are considering throughout the network PV integrated EV charging stations we are taking, and batteries we are considering storage systems. Throughout the network smart meters we are considering, and we have a rooftop systems are there at commercial level, industrial level and household level also. Okay, this is what. And one more I told you, throughout the network, we have wind farms are there, national highways, we have solar parks are there, we have EV PV charging integration stations are there. So that we have controlling is very, very good. Okay, and losses are reduced. And what we are doing along with that, we are using data centers we are using. So we are storing the data in the cloud. So how GPS system we are using for present, where the fuel station like that. So how much amount of power is available in each station. So everything can be, data can be collected and which will be stored in the cloud, easily can be accessible. How far the PV integrated EV charging stations are there, everything can be collected through this. Okay. Next, we have seen how the generation, transmission, distribution levels we have seen, the future grid we have seen. What about microgrid and impact of distributed energy resources on the utility grid we have seen, the benefits of DER we have seen, then essential elements of smart grid also we have seen. Okay. Then after that we have seen fundamental applications and foundation level enabled application what we have also we have seen. Then once it is done, we have seen 99% of energy electricity is covered. Installed capacity was 446, but now it is 450 gigawatt. Okay. Then after that we have seen residential consumption by residential, industrial, agricultural, commercial and traction we have seen. Then sector wise, central sector 23% share is there, Installed capacity, state 23 or 24, and private sector 53% is there. So next we have seen installed generation capacity. Fuel wise we have seen. What is that? So we have seen fuel wise, that is fossil fuel share is 54 percentage, non-fossil fuel is 46 percentage. Okay. Total installed capacity including fossil and non-fossil fuels is 450 gigawatt as on date, like 31st August 2024. 450 gigawatt is installed. So we are expecting by 2030 full by 500 gigawatt by only non-fossil fuels. Remember that. Only our target is without coal, or we want to exclusively go ahead with renewable energy. Okay. So then after that, how it is increased year by year, we have seen approximately 5 to 10 percentage of growth increase to meet the increase in the demand. Okay. Then this is what, how much is installed percentage, then how much is generated also we have seen. Okay. This is this is by installed capacity by region wise, north, west, southern, eastern, northeast, the region wise we have seen. Okay. Then last we have also seen what, then NSGM architecture also we have seen. So NSGM architecture, what it consists of? It is a three-tier structure which consists of tier one is Ministry of Power, tier two is both financial committee and the technical committee will be there, chaired by secretary of ministry power and the chairperson of CEA. Then we have four NSGM units are there: policy planning, monitoring, data management, R&D unit, and training and placement. So how this will be done? So this is what. So tomorrow I will try to start from the PV. Okay, then modeling of PV systems, PV cell, PV module, PV array. So what type of materials we are using? Okay, so then after that, one by one, if it is series connected, how it is, parallel connected, how it is, how the IV PV curve characteristics will be vary, by using shading conditions, how it will vary. Then if possible, modeling of PV systems also I will explain you. So please let me know if you have any queries. Now it is open for the queries. If you have any queries, you can ask me.
No, sir, no any queries.
Okay. Sure, ma'am. From participant, no queries.
Hello,
No, no,
madam.
sir.
Yes, sir.
Hello.
Yes,
Sir,
please.
Dr. Suresh, sir. Namaskar.
Yes, sir. Yes, sir. Tell me, sir.
Sir, it was very nice presentation. The
Thank you.
data and all what you presented is excellent. I just wanted to ask you, sir. You said that past structure of grid and present structure of grid.
Hmm. Hmm.
So it seems that presently the grid has become very much complicated compared to the
Hmm.
past one, telephonic
Hmm.
conversation and present grid structure.
Hmm.
So,
Hmm.
does the present engineers find it difficult to troubleshoot
Ah,
or maintain the things
sir,
in
that's
place?
what. Sir, one of the grid limitation is that only, sir. Actually, understanding of the people who are available in the substations, their lack of awareness is there. If possible, tomorrow, Smart Electric Grid, I will explain you what
Yeah.
is that lack of awareness is there by the substation people to adapt the technologies which are developed. So that is the reason it is delayed. Earlier they have considered 2020 plan. If you see NEMP plan, now it
Yeah.
is up to 2030 it is going. So awareness they want to increase. That's the reason here I have shown you they are planning which one. There is the projects, training and capacity building unit they have considered,
Okay.
skill development things people are going to consider to increase the awareness,
Right. Right.
and they will build it. That is a problem, that was a problem, sir. So that's why they have considered specially one unit they have considered. If you observe here,
Yeah. Yeah. One section they have created, I guess.
yes, project
Training.
management unit they
Project
have
and training.
considered.
Right. Right.
So the skill development, because people are unaware of it, So they have considered that. If you observe here, I have shown you
So
that.
it has to be undertaken seriously and rigorously, I guess.
Yes, yes, yes. This one you see. Fourth one, the
Yeah.
project's management unit is there, which
Correct.
will train the people in such a way that to adapt this R&D, your field should be ready.
Correct. Correct.
If
Yeah.
time permits, I will explain you what are all the changes, what type of things it is considered.
Correct.
So if
Correct.
time
What type
permits,
of
tomorrow.
challenges? Yeah. What type of challenges
What
needed you are
that's what,
facing?
sir. What are all the functions? What are all the functionalities? How
Correct.
it can be addressed? I will try to explain you tomorrow if required.
Okay.
Actually, if possible, otherwise, first I'll complete solar system, then I'll come back here. Anything is okay. I will try to cover in these 5 days. What
Yeah.
are
Yeah.
the
Sure.
functionalities,
As per
expectations?
your leisure time, sir. No issue.
So opportunities what we are having, or
Right.
what are the expectations what are there. So everything I'll explain you. Good, sir.
Sure. Sure. Very
Mm.
nice. Thank you, sir. Thank you so much.
Thank you, sir. Any others? Any queries by others? I hope everything should understand or nothing understood. What? See,
I
these
think
five
no
days,
query there. No query.
these 5 days be interactive. I will try to give you the best from BTech graduate to till research scholar.
Yes. Yes.
Okay. See, from fundamental to till design aspect, the sessions will go. So you can extract more, and if you attend, okay.
Hello.
I will try to. Tell me,
One
sir.
more query has come, I guess.
Yes, sir. Datta Pawara. Excuse me.
Sir, please ask your question.
Yes, sir.
I think
Priyanka madam.
he has
Priyanka
moved.
madam. Can you
Yes, yes, sir. No,
can you
sir, actually
conclude?
there is some internet issue. So your voice is break sometime.
Pardon, madam. If any queries, you can take it and you can ask me. 5 days I will be here, or else Priyanka madam, you can conclude the session, madam. Okay.
Yes, yes, sir. Actually, there is no any query, sir, because you
Okay.
explained very well. Because this is a huge amount of data: solar, series configuration, parallel configuration, hybrid configuration, and you just explain it very smoothly, sir. So I just thankful to you for
Thank
today's
you.
session. On behalf of my team, behalf of my institute, thank you,
Thank
sir.
you. Thank you.
Just Priyanka ma'am,
Yes, sir. Yes.
are we going to get PPTs which sir is sharing right now?
Sir, definitely.
Please, please. Thank you so much. Yeah.
Okay. Okay. Thank you, sir.
Uh, Thank you.
So I declare today's session is concluded. Thank you, everyone.